In this video, I'll go through the Year 7 Geometry Test Preview Sheet. If you're following along with the preview sheet, you can use the timestamps in the description below to skip to question numbers that you'd like help with. Otherwise, I've put a description of what the sorts of questions are that we're answering for anyone else who'd like some help with particular questions. Question 1 wants us to measure and classify the angle below. Now, unfortunately, this program doesn't have a protractor on it. So we'll only be able to classify the angle, but what we might be able to do is we might be able to estimate rather than measure. Now, if we classify this angle, it is acute, and an acute angle is an angle that's anywhere between 0 degrees and 90 degrees, okay? Has to be less than 90. Once it hits 90, it's a right angle. So looking at this angle, I would estimate that this is roughly 60 degrees. It's a bit more than halfway. If we make this a right angle so that we can compare it, it's a bit over halfway, which would be 45. I'm going to guess that it's about 2/3 of the way up to 90. So I'm going to say 60. Question 2, again, we can't measure, but we can estimate, and we'll classify it. So this one is an obtuse angle. And an obtuse angle is one that's greater than 90 degrees, but less than 180 degrees. So somewhere in between those two. Again, if we were going to try and estimate this one looks to me like it's about halfway between, if this was a 90 degree bend. So I'm going to estimate that this one is about 135 degrees. It's definitely more than 90, it's definitely less than 180, and I'd say it's about halfway between them, which is 135 degrees. Question 3 would like us to create an angle. Now, again, I have a bit of a problem here because I don't have a protractor. I have got a ruler, so I'm going to do it this way, but you should use a protractor. You start by drawing a line, and then what you guys would do is use your protractor to find 50 degrees. So I'm just going to swivel my ruler until I hit that and draw it in. The important part of this is that it's asking us to construct and label an angle. Now, when you see this angle ABC, it's important that B is in the middle. It's named like that for a reason. The little symbol at the front, which is usually actually written like this, angle ABC, means that it's an angle. And your job is to come along and put letters in the right spots. You might even choose to put 50 degrees in here, and usually this is the symbol of an angle. In question 4, we're building another angle, we're drawing another angle. This time it's going to be an obtuse angle because it's between 90 and 180 degrees. And so this time when I go to draw this, my calculator's nor my protractor's not going to let me measure 180 degrees. So I'm going to do 30 degrees off the horizon because I know that using supplementary angles, that will leave this as 150 in the middle, which is what I'm after. And I need to label this one again. Again, look, it says angle XYZ. It's important that the letters go in the right place. And there's my constructed angle. Question 5, we need to find out the value of X. It'll be an angle, so it'll be in degrees. These two angles will add to give us 180 degrees. We call these supplementary angles. The algebraic way of answering this is that we know that X plus 65 degrees equals 180 degrees. if we go back and do the balance method like we did in the algebra unit of work, we need to remove the 65. It says to add 65, so I'm going to subtract 65. That eliminates it. Anything I do to one side of the equation, I must do to the other. My next line of working is all I have left is x, and on the right hand side, all I have left is 115 degrees. It's important not to forget your units, and in geometry, we usually write a justification for our angle, for our answer. So you might write in supplementary angles add to give 180 degrees, or you might abbreviate it like that. Question 6 is an example of complementary angles. So these angles form a right angle, or they add to give us 90 degrees. So in this case, if we were solving this algebraically, like in question 5, we'd say x plus 64 equals 90. And now we just do the balance method again. We need to get rid of that 64. So it says to add 64, so I'm at minus 64. Eliminates it. Anything I do to one side of the equation, I must do to the other. My last line of working is all I have left is x, and over here, all I have is 26 degrees. Don't forget your units, and that's because of complementary angles. Now you can just get your calculator and just say 90 minus 64 equals 26 and know that x is 26. The only reason that I've shown you the algebraic way of doing this for the last two is that when these questions start getting hard in year 8 and year 9, you'll need the algebra to be able to work it out when there's more than just two angles making these up. Question 7 is exploring the angle sum of a triangle rule. So the angle sum of a triangle is 180 degrees. What that means is if you add the three angles in any triangle up, they will be 180 degrees. So if you know what two of the angles are, you can find the unknown one. The easy way to do this particular question is just to get your calculator and type in 180 minus 55 minus 75 equals, and that will tell you what x is. But we're going to do it using algebra because this is a method that will always work no matter how hard the question gets. So we know that if we add those three angles together, we'll get 180, and that's what we're going to write. We're going to say angle x plus 55 degrees plus 75 degrees will give us 180 degrees. Now we're going to collect our like terms. So we have x, and we have 55 plus 75, which is 130, equals 180. Now I'm swapping to the balance method. It says to add 130. I'm going to take that away. That will cancel it. Anything I do to one side, I must do to the other. All I have left is x, and all I have left is 50 degrees. So the answer to this is that x is 50 degrees. Question 8 is another angle sum of a triangle being 180 degrees question. This time, instead of giving us a number for one of the angles, it's a right angle, and that little square tells you that that is 90 degrees. The little square is only used when there's 90-degree angles. So in this case, solving it just like the last one, if I add the three angles together, so I've got x, I've got 90, and I've got 37, all together that would add up to give me 180 degrees. So if I collect my like terms, I'll end up with x plus 127 equaling 180. Now I'll use the balance method. It says to add 127, so I'll take it away. That will eliminate it. Anything I do to one side of the equation, I must do to the other. All I have left is x, and all I have left is 53 degrees. Question 9 is an interesting question. There is a special rule that we can use which says that the external angle of a triangle is equal to the sum of the two opposite interior angles. And I'll write that down for you. It's a bit of a mouthful, but what it means is that in this case, x is simply the same as 60 plus 75. So x is 135 degrees. It's a nice fast way of answering this question, but if you can't remember that rule, what you could do is you could create your own pronumeral here, and you could solve for y first, and you'd find that y was 45 degrees, and then you could use this to work out x using supplementary angles instead. But if you can remember this way of doing it, it's much quicker. Question 10 explores the angle sum of a quadrilateral. So any four-sided shape, a quadrilateral, is 360 degrees if you add up all the angles. So this is just like the triangle ones. We know that if we take x and we add it to 115 and 115 and 65, so the four angles of this shape above, it will add up to give us 360. So if we collect our like terms, we've got x, and then we've got 115 plus 115, which is 230. 230 plus 65 gives us 295. That will give us an answer of 360. Changing to the balance method, just make that a nice neat 0. Changing to the balance method, it says to add 295, so I'm going to subtract 295, which will eliminate it. Anything I do to one side, I must do to the other. All I have left is x, and on the right, all I have left is 65 degrees. So x is 65 degrees. When you answer question 11, you've got a couple of options. You could look at these two angles and work out x based on supplementary angles. But seeing as we've done that previously, I'm going to do something a bit different. We're going to have a look at corresponding angles on parallel lines. And those angles are always equal. And at the moment, x and 39 are corresponding. When I see corresponding angles, I kind of see them as being on an F. So if you sort of imagine that as being a bit of a upside down F, when you do this one, it's simple as saying x is 39 degrees because of corresponding angles. And you will need to give your marker a justification for this, okay? So that way, if you're a person who solved it using corresponding, they understand, and someone else might decide that they want to do supplementary angles, either is fine, you just have to justify the way that you've done it. Question 12 is also looking at the rules of geometry. You need to try and work out what x is, but you're not going to be able to do it in one move. So, we did corresponding angles last time, which we could do here. We could give ourselves another pronumeral in here like this, and I could say, okay, well, y is 80 because of supplementary angles, and then x is also 80 because of corresponding, because I can see another F sort of shape here. But let's just try something a bit different that uses a couple of extra rules here. I think I'm going to use a y here because now I can tell you that y is equal to 80 degrees because of co-interior angles. So co-interior angles between parallel lines add to give up to 100 or a total of 180 degrees. And I kind of see co-interior angles as being like a C. Sometimes the C is back to front like it is here, or sometimes it's upside down. But either way, if you've got two angles like these ones in between parallel lines, they will add to give you 180 degrees. Now, we haven't finished the question yet. X is also 80 degrees because vertically opposite angles are equal. And these two angles are right opposite one another at a point, and so those angles will always be equal. So the trick to these questions is that there's lots of different ways to answer them, and this is just one of the ways to answer each of these questions. It's not the only way, it's just how you best see it. There's not one way that's more right than the other, but there are sometimes ways that are a bit more efficient than other ways.